This is Dr. Mamta from Government College Faridabad. Today I am going to tell you something about Lagrange's linear equation. Now first of all we have to check it out the definition of Lagrange's linear equation. The definition is the linear partial differential equation of order first is called as Lagrange's linear equation. This equation is of the form P plus QQ is equals to R, where capital P, capital Q and capital R are the functions of x, y and z. Here we knew it very well. Z is a dependent variable and x and y are said to be the independent variable. Then we have to be talk about the general solution. Now the general solution of the PDE equation P plus QQ is equals to capital R is f of uv is equals to 0. Okay, where capital F is arbitrary function of u is equals to C1 and v is equals to C2. Here C1 and C2 is said to be the constant. Now u is equals to C1 and v is equals to C2 are the independent solutions of the auxiliary equations dx upon capital P is equals to dy upon capital Q is equals to dz upon capital R. Now some solved examples are given over here. First of all the question is there. Find the general solution of x square p plus y square q is equals to x plus y of z. Now we have to be talk about the solution. What is the solution? So first of all we have to be check the auxiliary equation. For this we have to be compare this with the Lagrange's PD equation. What is that? That is PP plus QQ is equals to R. So now we have to be get it out the value of dx upon capital P की value यहाँ पर x square है is equals to dy, capital Q is equals to y square is equals to dz and capital R is equals to x plus y into z. Now this is the equation. First of all we are just getting out two equation, then we have to be integrating on the both side and we are just getting out u is equals to x inverse minus y inverse. That's meaning 1 upon x minus 1 upon y. This is equals to C1. We just have to be assume. So this is the value of u. Now we have to be talk about the another value of v. So therefore we have to be take it out dx minus dy, that divided by x square minus y square is equals to dz upon x plus y of z. So now what we have to done out over here, d of x minus y divided by x plus y and x minus y is equals to dz of x plus y into z. Now what we have to done out, both the side x plus y has to be cut it out over here, then we will get it out the equation d of x minus y divided by x minus y is equals to dz upon z. Now integrate on both sides, we are just getting out log of x minus y is equals to log z plus log of C2. That's meaning we are just getting out the value of v. V is equals to x minus y into z inverse, means it would be equals to C2. We just have to be assume that. Now we have to be check it out the general solution. The general solution is given by f of uv is equals to 0. Now we have to put it out the value of uv, then we will get it out capital F of x inverse minus y inverse comma x minus y into z inverse is equals to 0. This is the general solution for this equation. Another example is given over here. We just have to be solve the example x square into y minus z plus y square into z minus x of q is equals to z square of x minus y. Now we have to talk about the solution. What is the solution? The auxiliary equations are given by, we knew it very well, dx upon capital P is equals to dy upon capital Q is equals to dz upon capital R. So what is that? Here the values of capital P is equals to x square into y minus z, capital Q is equals to y square into z minus x and capital R is equals to z square into x minus y. Okay, so we have to be put it out all the values, then we will get it out dx upon x square divided by y minus x is equals to dy upon y square divided by z minus x is equals to dz upon z square divided by x minus y. Now we have to be check this. So first of all we just have to be add of all, then we are just getting out dx upon x square plus dy upon y square plus dz upon z square divided by y minus z plus z minus x plus side. So whenever we are just getting out u is equals to 1 upon x plus 1 upon y plus 1 upon z, and this would be equals to a, we are just assuming here. Again we have to be take it out the value of v. So for this we just have to be take it out x inverse of dx divided by x into y minus z is equals to y inverse of dy is upon y into z minus x is equals to z inverse of dz divided by z into x minus y. Okay. Then on adding, we are just getting out dx upon x plus dy upon y plus dz upon z is equals to 0. Now we have to be integrate on both sides, and we are just getting out v is equals to x, y, z. We are just getting out this value as a v, means v is equals to हो जाएगा x, y, z is equals to v. This is the second equation. So first we are just getting out the value u and v both, and we have to be put it out in the general solution. Then the general solution is given by f of x inverse plus y inverse plus z inverse of x, y, z is equals to 0. So these are the examples which we have done out for the Lagrange's linear equations. Now we have to be talk about another topic, that is the homogeneous linear partial differential equation with the constant coefficient. Okay, so homogeneous linear PD, we just have to be checked. So what is the what is the definition here? Equations in which the partial derivative occurring are all of same order with the degree 1 and the coefficients are constant. Such equation are said to be the homogeneous linear partial differential equation with the constant coefficient, and the general form is del n z upon del x raised to the power n plus a1 of del n z upon del x raised to the power n minus 1 into del y plus a2 of del nz upon del x raised to the power n minus 2 into del y square plus and so on up to an of del nz upon del y raised to the power n is equals to capital F of xy. Okay, we just have to be assume here capital D is equals to del upon del x and D dash is equals to del upon del y. Okay, then nth order linear partial differential equation is given by, we just have to put it out, all the value is in the capital D and D dash. Then we are just getting out over here d of d raised to the power n plus a1 of d raised to the power n minus 1 and of d dash plus a2 d raised to the power n minus 2 and d dash square and so on up to an and d dash raised to the power n of z is equals to a function of xy. Or you can say small f of function d and d dash of z is equals to capital F of xy. We are just assuming this equation as equation number 1. The complete solution of this equation consists of two parts. One is said to be the complementary function and second is said to be the particular integral. Now we have to be talking about the complementary function. Now what is the complementary function? So complete solution के लिए first of all we have to be check it out f dd dash of z and we have to be take it out is equal to 0. Okay, so what is the rule to find out the complementary function? That's meaning CF. Consider the equation. First of all, the equation, given equation is, we are just consider here del 2z upon del x square plus k1 of del 2z upon del x del y and plus k2 of del 2z upon del y square is equals to 0. Now what we have to done out? First of all, we have to put it out the values of capital D and D dash, and we are just getting out d square plus k1 of dd dash plus k2 of d dash square of z is equals to 0. Now we can say this equation number second. Then the auxiliary equation of this equation is given by d square plus k1 of dd dash plus k2 of d dash square is equals to 0. Now we have to be put it out the value of capital D is equals to small m and capital D dash is equals to 1. And we have to be put it these values in the equation. Then we can get it out the auxiliary equation m square plus k1m plus k2 is equals to 0. Now we can say this equation is equation number 3. Okay, so cases are arises over here if the equation 3 has two distinct roots. Because this equation is a quadratic equation, then we can get it out two values, that is m1 and m2. Then the complete solution of this equation is given by z is equals to f1 of y plus m1x plus f2 of y plus m2x. This is the case 1. But whenever we have to be talking about the case 2, whenever the roots of the equations are equal, that's meaning m1 is equals to m2, then the complete solution of this equation is given by z is equals to f1 of y plus m1x plus x of f2 of y plus m1x. So this is the funda by which we can find out the complementary function. Now we have to be talk about the rules to find out the particular integral. So what is that rule? So first of all we have to be consider the equation. What is the equation? differentiation equation is d square plus k1 of dd dash plus k2 of d dash square of z is equals to capital F of xy. Okay, that's mean f dd dash of z is equals to capital F xy. Then particular integral is given by is equals to capital F of xy and divided by f of dd dash. Okay, so for particular integral we just have to be divided it into the cases. So case 1, whenever fxy is equals to in the form of e raised to the power ax plus by. If we have then the particular integral is given by 1 upon f dd dash of e raised to the power ax plus by. It would be equals to 1 upon f of av e raised to the power ax plus by, and this is compulsory to take it out. F of av shouldn't be equals 0. Okay, so if f of ab is equals to 0, then what we have to run out, we have to be take it out. D minus a upon b of d dash is a factor of f dd dash. So this is the case 1. Then particular integral is equals to x into e raised to the power ax plus by. Okay, if f of ab is equals to 0 and d minus a upon b d dash whole square is a factor of f dd dash, then we have to be take it out. Particular integral is equals to x square divided by 2 and e raised to the power ax plus vy and so on. Okay, now we have to be talk about the case number 2. What is that? F of xy is given sin of mx plus ny or cos of mx plus ny. If the particular integral we have to be find out whenever capital F is in the form of sin or cos. Okay, then particular integral is equals to sin of mx plus ny divided by f of d square comma dd dash comma d dash square. Then we have to put it out. D square is equals to minus m square, dd dash is equals to minus ka mn, and d dash square is equals to minus ka n square. Okay, then case 3rd, whenever the f of xy is in the form of x raised to the power m and y raised to the power n, then the particular integral is given by 1 upon f of dd dash x raised to the power m into y raised to the power n, and it would be equals to f of dd dash whole inverse and x raised to the power m and y raised to the power n. Then we have to be expand f of dd dash inverse in the ascending powers of d or d dash and operating on x raised to the power m and y raised to the power n term by term. So this is the 3rd case. Now we have to be talk about the another case, that is the case number 4. So when f of xy is any function of capital when f of xy is any function of x and y, then particular integral is equals to 1 upon f dd dash of fxy. Okay, what is that? 1 upon d minus md dash of fxy is equals to integral f of x comma c minus mx into dx. Okay, here d minus m d dash is a factor of f dd dash where c is replaced by y plus mx after integration. So these are the 4 cases in which we have to be find out the particular integral. Now we have to be talk about some solved examples. First of all, first is given, find the solution of PDE d raised to the power 3 minus d dash raised to the power 3 plus thrice of d dash square minus the thrice of d square and d dash of z is equals to 0. Then what is the solution for this PDE? Now we have to be talk about the solution. The auxiliary equation of the given equation is given by the auxiliary equation m cube minus 1 plus thrice of m. We are just putting out the values. Then it would be equals to m cube minus 1 plus thrice of m minus 3 of m square is equals to 0. Now we have to be take it out. Capital D is equals to small m and d dash is equals to 1. Then we are just getting out this auxiliary equation. On solving this equation, we just have to be get it out 3 roots, that is the m is equals to 1, 1 and 1. These are the repeated roots. That's why the complete solution is given by f1 of y plus x of f2 of y plus x plus x square of f3 of y plus x. For being a repeated solution, here we have to be use the rule for repeated values of m. Now another question is giving here, solve the PDE d raised to the power 3 plus 4 time of d square d dash minus 5 of d dash of z is equals to 0. The solution is given by the auxiliary equation is given by m raised to the power 3 plus 4m raised to the power 2 minus 5m is equals to 0. Then on solving, we are just getting out the value m is equals to 0, 1 and minus 5. We are just getting out the general solution is equals to z as a complementary function. Z is equals to f1y plus f2 of y plus x and plus f3 of y minus 5x. These are the examples in which we have to be find out the complementary function only. Some examples are given over here in which we have to be find out the complementary function and a particular integral. Okay, so complementary functions we have learnt out how to find out. First of all, we have to be get it out the value of m, then complementary functions easily find out. Okay, the two rules are given in our PD. Okay, now particular integral की बात करते हैं तो e raised to the power 2x plus 4y is given divided by d square plus 3 of dd dash minus the 4d dash square. Then what we have to done out here, we just have to be put it out the value d is equals to 2 and d dash is equals to 4. Then solving we are just getting out e raised to the power 2x plus 4 divided by minus 36. So this is the complete solution by adding the complementary function and particular integral. So by adding both the things, we are just getting out the complete solution. Thank you so much for watching.